This problem and all other practice problems for Calc 2 here at Rutgers can be found in Sarai Studies. A link is in the description box below. Does this series converge or diverge? We're going to be using the LCT, so the limit comparison test. The rule is based on the limit as it approaches infinity of a of n over b of n being rho. That's how we pronounce it. It's not pronounced p. And so there are three rules. I always like to start with the bottom two. So rho is equal to 0, rho is equal to infinity. And the series b of n converges, diverges. Then the series a of n will converge, diverge. The top one is a little different. This is when rho is not 0. And the series b of n either converges or diverges. Whatever it does, then the series a of n will do the same thing. Recall that DCT is IBBCC and LCT is IBBLC. One letter difference. In DCT we compare, in LCT we find the limit. So the first letter is I, stands for information. The information that we know plus the information we need. So A sub n is always the given sequence. B sub n is what we need, we don't know what that is, which brings us to our second step, which is B, find B of n. So the way we do that is we take our given sequence and we ask ourselves at large n, so when n gets really, really, really big, what does this become? In essence, what becomes insignificant as n approaches infinity? To see this, it's really nice if we were to simplify this first. So this becomes n squared plus n over n cubed minus n squared plus n minus 1. So in this case, it's easier. If you were to plug in infinity, what would become insignificant? Well, subtracting 1 from all these infinities is not really going to make a difference, so the 1 is going to be crossed out. This infinity cubed overpowers any squares and any 1, so these will also be crossed out. And this infinity squared overpowers this simple infinity, so this is also going to be crossed out. So we're left with, at large n, that's going to become n squared over n cubed, which can be simplified as 1 over n. And that is our b of n simplified. Which brings us to step 3. We want to find the behavior, so B for behavior of the series b of n, because that's going to determine the behavior of the series a of n along with the rho, the limit that we find later on. So how does the series b of n behave? So what is the series b of n? So it starts from n is equal to infinity. I get these from the original series. B of n is 1 over n. I immediately recognize that this is in the form of 1 over n to the p, where p is equal to 1, so I'm going to do the p-test. The way that I remember the p-test rule is by remembering the movie rating PG-13. So p being greater than 1, forget the 3, converges always comes first, and then the opposite will be true. In this case, p is equal to 1, which means that the series is going to diverge. So by the p-test, where p is equal to 1, the series b of n diverges. So the series diverges. And so we have that this is an option now, and we know that this is going to diverge, and these are always going to have to be the same. So these are two possible conclusions. They're the same conclusions, but we have to figure out what rho is because we have to justify those conclusions correctly. So that brings us to our next step, which is find rho, or find the limit, because that's what this is. It's just L, same thing. So remember, it's the limit as it approaches infinity of a of n over b of n. So I'm going to grab a of n. And remember, no one really actually does the over b of n part. We just take b of n and we flip it. So n goes up here, 1 goes down here, so that's just n. And multiply by it. We're essentially just multiplying by the reciprocal. In this case, I would simplify this. We already did simplify that, thank God. So let me just drop that down here. We're still multiplying by n. Let me move this here. I can go ahead and distribute this n. So that becomes n cubed plus n squared. And so now we have a really nice, beautiful rational fraction, and we know how to deal with those. We just divide every term by the term with the highest power in the denominator, and so that's n cubed. So we're going to divide every term by n cubed. So this cancels out to be 1, this cancels out to be 1, this cancels out to be 1 over n, this cancels out to be 1 over n squared, this cancels out to be 1 over n. So we have the limit as n approaches infinity of 1 plus 1 over n, 1 minus 1 over n, plus 1 over n squared minus 1 over n cubed. When we plug in infinity for the n's, we get the following. We understand that infinity squared is still just infinity, infinity cubed is still just infinity, and anything divided by infinity, or as n approaches infinity, goes to 0. So essentially, we have that this is equal to 1 over 1, which is just 1. So we have that rho is equal to 1, which is a non-zero number. And so therefore, if this is true, and this is true, then we can say that this is true, that the series that was given to us diverges. And that is our answer, and that brings us to step number 5, which is to conclude and a nice beautiful sentence. So since the blue part, the series B of n diverges, B of n is 1 over n, diverges by the p-test, where p is equal to 1, that's our blue part, and then our green part, I literally just take the limit, say what it's equal to and what it's not equal to. It's a non-zero number, that's our green part, comma, the limit comparison test implies that the given series A of n diverges as well. So here is our answer, and these are our justifications, and I'll see you in the next video.